Look up. Not right now, not literally. But think about the last time you did. Think about the last time you stepped outside at night and turned your face toward the sky. What did you see? A handful of stars, probably. The moon, maybe. If you were in a city, perhaps nothing more than a pale orange haze where the darkness should have been. A flat, featureless ceiling of light that told you nothing, revealed nothing, gave you the impression that above this planet there is simply a warm, empty dome of scattered photons and not much else. And you looked at it for a moment, and then you went back inside. Here is the question we are spending tonight together. The question that, once you start pulling at it, does not stop unraveling. What if everything you have ever believed about the sky, everything you have ever assumed about what you are seeing when you look up, is incomplete? Not wrong in the simple sense, not a lie, but a profound, layered, accidental deception, constructed not by anyone in particular, but by the combined effect of physics, technology, biology, history, and the particular limitations of human perception applied to a universe of staggering complexity? What if the sky you know is not the sky that is? Tonight, we take that question apart, layer by layer. From the most immediate, the sky above a modern city, buried under artificial light, to the most distant and the most strange, the horizon of what physics itself will ever allow us to know. We will go from the photons scattering through your atmosphere right now to the edge of the observable universe, from the stars that may already be dead to the 95% of reality that has no name yet, from Betelgeuse's possible explosion in your lifetime to the darkness beyond the cosmic horizon that no instrument, no matter how powerful, can ever pierce. By the end of tonight, you will understand, perhaps for the first time, what you are actually looking at when you look at the sky. This is Sleepy Cosmos. Subscribe if the dark has always felt like it was hiding something. We begin now. Let us start with something immediate, something you can verify tonight if you choose to, simply by walking outside. The sky above you is not dark. Not if you live in or near a city. Not if you live in or near a suburb. Not, in fact, if you live within 100 miles of any significant concentration of human settlement. The sky above you, even on a clear night, even with no clouds, is glowing. It is glowing with a persistent, diffuse, orangish-white haze that is so pervasive that most people who have grown up in the modern world have never experienced anything else and would not recognize true darkness if they saw it. This is called light pollution, and it is one of the most significant, most underappreciated alterations that humanity has made to the natural world. Light pollution is not complicated in its mechanism. You have artificial lights. Those lights emit photons in all directions, including upward. Those upward photons strike molecules and particles in the atmosphere, nitrogen, oxygen, aerosols, dust, and scatter. The scattered light travels sideways and downward, illuminating the sky from within. The result is a diffuse glow above any populated area that can be detected from hundreds of kilometers away, and that effectively erases the stars by reducing the contrast between their light and the background sky to the point where only the brightest survive. A 2023 study published in the journal Science, one of the most rigorous assessments of global sky brightness ever conducted, analyzed data from over 50,000 observations made by citizen scientists in 44 countries between 2011 and 2022. The finding was, by the lead researcher's own description, shocking. The average brightness of the night sky had increased by 9.6% per year over that period. Not per decade, per year. That is a rate of increase that doubles the sky's brightness every 8 years. A child born in a light-polluted area who can see 250 stars from their backyard today will, by the time they are 18 years old, be able to see approximately 100. Not because the stars have changed, because the sky will have become more than twice as bright. This is not an environmental statistic in the abstract. It is the erasure of something fundamental to the human experience. For the entirety of our species' existence, for the 200,000 years that anatomically modern humans have been walking this planet, the night sky was one of the most constant and universal features of their environment. Everywhere, in every culture, on every continent, human beings went outside at night and saw the same thing. A black sky, alive with stars, so thick with light that in truly dark conditions the Milky Way casts a shadow. The Milky Way casts a shadow. This is not hyperbole. From a truly dark sky, the combined light of the galactic band is bright enough to throw faint shadows. On the ground at your feet, you can read by a full moon. You can navigate by the stars with precision. The night sky, unobstructed by artificial light, is not dim. It is luminous. It is extraordinary. It is the original theatre of the human imagination. Today, approximately 1/3 of humanity cannot see the Milky Way from where they live. 1/3. That includes most people who live in Europe and North America. The glow of Los Angeles can be detected from more than 300 kilometers away. The glow of the northeastern seaboard of the United States blends with the glows of its cities into a single continuous luminous mass visible from space. Vincent van Gogh painted The Starry Night in Saint-Rémy-de-Provence, France, in 1889. He painted what he saw from a window in the institution where he was staying. The swirling, churning, impossibly alive sky he depicted was not an artistic exaggeration. It was a realistic representation of what a clear night in rural France looked like before electricity, before industrialization, before the transformation of the natural darkness into a permanent orange haze. Today, the Milky Way cannot be seen from Saint-Rémy. The painting depicts a sky that no longer exists there. Van Gogh painted the sky as it was. We live in the aftermath of its disappearance. But even if you could remove all of the artificial light, even if you could somehow restore the pristine darkness of a pre-industrial night, the sky you would see would still not be the sky that is. Because what you see when you look up at the stars is not what the stars are now. It is what they were. Light travels at approximately 300,000 kilometers per second. That is the fastest any information can move through the universe. There is no exception to this limit, no shortcut, no channel through which a faster signal can pass. The speed of light is not merely a physical constant. It is a structural feature of reality, woven into the geometry of space-time itself. And, because light travels at a finite speed, it takes time, sometimes a very long time, to travel from any astronomical object to your eyes. Consider the nearest star. Proxima Centauri is approximately 4.24 light-years from Earth. The light you see when you look at it tonight departed from its surface 4.24 years ago. What you are seeing is not Proxima Centauri as it is now. You are seeing Proxima Centauri as it was in early 2022. You have no information about what is happening there tonight in the present tense. That information is still in transit. It will not arrive for another 4 years. This is already strange enough to sit with for a moment. The nearest star to our sun is not accessible to us in real time. We are perpetually looking at its past. Now, scale upward. The star Vega, one of the brightest in the northern sky, is 25 light-years away. When you see Vega, you are seeing light that left it 25 years ago. The star as it exists tonight is invisible. You are looking at a photograph taken in the year 2001, played back to your eyes by photons that have been traveling through empty space ever since. Deneb, one of the most luminous stars visible to the naked eye, is approximately 1,400 light-years distant. Its light left it roughly 600 years ago, when Europe was in the late Middle Ages, when the Black Death had only recently subsided, when no European had yet set foot in the Americas. Whatever you see when you look at Deneb is a message from a world that was already ancient by the time your grandparents were born. The Pleiades, the famous Seven Sisters cluster visible in the autumn and winter sky, are approximately 440 light-years away. Their light departed during the Elizabethan era, when Shakespeare was writing his plays, when Galileo was a young man, and those are the naked eye examples. They are among the closest, most accessible objects in the sky. When you turn a telescope toward the Andromeda Galaxy, the most distant object most people will ever see with their naked eye, a faint smudge of light in the constellation Andromeda. You are looking at light that has been traveling for approximately 2.5 million years. When that light departed, modern humans did not exist. Our ancestors were a species of early hominid, using stone tools in Africa, with no concept of language, no concept of fire, and no concept of the vast spiral galaxy they were embedded within, or the other spiral galaxy whose ancient light would one day reach the descendants of their descendants and be called beautiful. The night sky is not a view. It is a time machine. Every direction you look is a different distance, which means a different era. When you scan across the sky, you are sweeping your gaze through a mosaic of pasts, layered on top of each other from 4 years ago to 4 billion years ago, all arriving at your eyes simultaneously and appearing, deceptively, like a single, coherent picture of the present. There is no present in the night sky. There is only an elaborate collage of many different pasts. Now consider what this means for specific objects you know by name. Betelgeuse. One of the most recognizable stars in the sky. The red star that marks the left shoulder of Orion, visible in winter from most of the northern hemisphere. It is a red supergiant, a star so enormous that if it were placed at the center of our solar system, its surface would extend past the orbit of Jupiter. You could fit more than 300 million suns inside Betelgeuse by volume, and it is dying. Betelgeuse is in the late stages of stellar evolution. It has burned through its hydrogen, through its helium. It is currently fusing carbon in its core, working its way down the chain of available nuclear fuels, each step faster and more violent than the last. Each step bringing it closer to the moment when the iron core it is building can no longer sustain fusion, can no longer hold itself up against its own gravity, and collapses inward in a fraction of a second before rebounding in the most violent explosion a single star can produce, a supernova. When Betelgeuse goes supernova, it will become briefly brighter than anything in the sky except the moon. Possibly as bright as the half-moon, but concentrated into a single point of light. It will be visible in daylight. It will cast shadows at night. For months, humans will step outside and see a second moon in the shoulder of Orion. Not diffuse and rounded, but a blazing, impossible point of fire. When will this happen? The answer, as best as science can determine, is sometime in the next 100,000 years, possibly much sooner. But here is the part that matters for our question tonight. Betelgeuse is approximately 650 light-years from Earth. When you look at it tonight, you are seeing it as it was in the mid-1300s. You are seeing the star as it existed around the time the Black Death was sweeping through Europe. The information about what Betelgeuse is doing right now, in the year 2026, in this particular moment, will not reach Earth for another 650 years. And this means something extraordinary is possible. It is possible. Astronomers consider it genuinely unlikely, but it is physically possible. That Betelgeuse has already exploded. Not will explode, has exploded. It might have gone supernova in the year 1500, in the year 1800, in the year 2000. The explosion might already be complete. The stellar core might already have collapsed. The shockwave might already be expanding outward at a significant fraction of the speed of light, sweeping through the ancient outer layers of the star and igniting them in a cascade of nuclear fire that will eventually outshine every other star in our sky. And you would not know. No one on Earth would know. The light from that explosion has not arrived yet. It is still in transit. And when it does arrive, in 2026 or 2100 or 2250 or some other year, no one will be expecting it, because we are watching a star that is 6.5 centuries out of date. One night, perhaps decades from now, perhaps centuries, a person will step outside to take a walk, or a dog, or simply to look at the sky the way people occasionally still do. And they will see that Orion looks different. They will see a light where no light has been before, blazing above the hunter's shoulder, brighter than anything they have ever seen in the night sky. They will be the first humans to learn what has already happened. They will be witnessing not the beginning of an event, but the announcement, delayed by 650 years, of an event that is already over. This is what the sky actually is. Not a window, an archive, a system of delayed messages, arriving from events that have already concluded, carrying news of a present that is no longer present. And Betelgeuse is close. On the scale of the galaxy, it is practically a neighbor. The Milky Way is approximately 100,000 light-years in diameter. The light from the far side of our own galaxy has been traveling for 100,000 years to reach us. When that light departed, modern humans had only recently arrived in Europe. The Neanderthals were still alive. The cave painters at Lascaux would not pick up their ochre for another 70,000 years. We are looking at the far side of our own galaxy, and we are looking at it from before recorded human civilization existed. When we look at other galaxies, the millions of galaxies in the Virgo cluster, 60 million light-years away, we are looking at them as they existed when the dinosaurs were in their final years, just before the asteroid impact that ended the Cretaceous. When astronomers observe galaxy clusters at a distance of 1 billion light-years, they are looking at structures as they existed before complex multicellular life had evolved on Earth. When the James Webb Space Telescope peers at the earliest galaxies, some of them more than 13 billion light-years distant, it is seeing the universe as it was less than a billion years after the Big Bang, in a time when none of the atoms that make up your body yet existed in their current form, when the first stars were just beginning to ignite. The telescope is not just another device, it's a time machine into the further we look, the older what we see. This is beautiful. It is also, when you hold it in your mind and refuse to let it soften into metaphor, deeply strange. The observable universe is not a sphere of space that we can examine. It is a sphere of past. Everything we see is already gone, in the strict sense that the light we are receiving shows us a state of the universe that no longer exists. The universe we observe and the universe that exists are two different things. We are prisoners of the speed of light, receiving ancient dispatches from a reality we can never directly access. But the sky's deception goes deeper still, because even in the daytime, even looking at the sky above you on a clear afternoon. What you are seeing is a fabrication, a performance, an optical illusion created by a specific and mundane interaction between sunlight and molecules. The sky is not blue. This requires some clarification. The sky appears blue. Your experience of the sky is genuinely blue. But the sky's blueness is not a property of the sky itself. It is a property of the light, the atmosphere, and your eyes, working together to produce an impression of color that has no objective existence beyond the interaction of these three things. Here is what is actually happening. Sunlight is not yellow. This is the first misconception to clear away. Sunlight is white, or rather, it is a mixture of all visible wavelengths of electromagnetic radiation, spanning from the deep reds to the far violets. When you see sunlight as a yellow-white glow, you are seeing the collective effect of all those wavelengths mixed together, filtered through your eye's particular sensitivity to color. When sunlight enters Earth's atmosphere, it encounters billions of nitrogen and oxygen molecules. These molecules are much smaller than the wavelengths of visible light, and when light waves encounter particles much smaller than their own wavelength, something happens. The particles absorb the light and re-emit it in a new direction. This is called Rayleigh scattering, after the 19th century physicist John William Strutt, Lord Rayleigh, who worked out its mathematics in 1871. The key feature of Rayleigh scattering is that it is strongly wavelength dependent. Specifically, shorter wavelengths scatter much more than longer ones. The scattering intensity scales with the inverse fourth power of the wavelength. Blue light has a wavelength of roughly 450 nanometers. Red light has a wavelength of roughly 700 nanometers. When you apply the mathematics, blue light scatters approximately 9 to 10 times more intensely than red light. The result is exactly what you observe. When sunlight enters the atmosphere, the blue wavelengths are scattered in every direction. Sideways, downward, upward, toward your eyes from every patch of sky you can look at. The red wavelengths pass through more directly, without much scattering, making it to the ground in a relatively undiluted beam. The sky appears blue because the entire atmosphere is full of scattered blue photons, bouncing between air molecules and arriving at your eyes from every direction simultaneously. But here is what this actually means. The blue you see when you look at the sky is not a thing that is there. It is a process. It is the statistical outcome of trillions of individual photon-molecule interactions, each one redirecting a fragment of solar energy in a slightly different direction, summing to a diffuse light that appears, to your perceptual system, as a uniform blue ceiling. There is no blue in the sky. There is scattering in the sky. And your brain, interpreting the pattern of light arriving at your retina, constructs the experience of blue from a physical process that is happening at a scale far below your ability to observe directly. Strictly speaking, the sky is not even blue in the sense you probably mean. The actual color of scattered sunlight at the frequencies your atmosphere produces most abundantly is not blue. It is violet. The sky, if your eyes were more sensitive to the violet end of the spectrum, would appear violet-purple during the day. The reason it appears blue rather than violet is that your retinal cone cells are more sensitive to blue wavelengths than violet ones, and additionally, the sun produces somewhat less violet light relative to blue. Your brain does not see violet because your eyes are not particularly good at detecting it. The sky is blue partly because of physics, and partly because of the specific tuning of human color vision, which was evolved for entirely different purposes on an African savanna millions of years ago and was not designed to accurately represent the color of atmospheric scattering. The sky you see is a collaboration between the physics of scattering and the biology of your eyes. Neither one alone produces it. And the color you experience is not the color that is objectively there, but the color that your perceptual system constructs from the available data. This is not a trivial point. It is the beginning of a much larger one. Consider what happens at sunset. When the sun approaches the horizon, the angle at which its light strikes the atmosphere changes. Now, instead of traveling a relatively short path down through the atmosphere to reach your eyes, the sunlight is traveling nearly horizontally, threading through an enormously longer column of air. That column of air contains far more nitrogen and oxygen molecules than the vertical column does. What happens to the blue light? It scatters, and scatters, and scatters again. Each time it scatters, it is redirected away from your line of sight. By the time the sunlight has traveled a long horizontal path through the atmosphere to reach you at sunset, nearly all of the blue wavelengths have been scattered away. What arrives is what remains. The red and orange and yellow end of the spectrum, the wavelengths that are too long to scatter efficiently, that have made it through the gauntlet of air molecules without being deflected. This is why sunsets are red. Not because the sun has changed, not because the atmosphere has changed, because the geometry of your position relative to the sun has changed, and that change in geometry reveals a different filtering effect in the same atmosphere you always look through. The sky is not presenting you with a fixed image. It is presenting you with a dynamic system in which your position, the sun's position, the density and composition of the atmosphere, the presence or absence of particles and aerosols all interact continuously to produce the light pattern that arrives at your eyes. The sky you see at noon is not the sky you see at sunset. They are the same physical sky, but different because you are standing in a different relationship to the light source, and the atmosphere is responding differently to that relationship. When volcanic eruptions inject sulfate aerosols into the stratosphere, sunsets become more vivid. The aerosols provide additional scattering material, enhancing the red and orange. The painter J.M.W. Turner, who was active in the early 19th century, is noted for the extraordinary, almost hallucinatory quality of his sunset paintings. The blazing yellows and oranges and whites that seem almost hyper-real. Researchers have pointed to the eruption of Mount Tambora in 1815 as a potential cause. The volcanic winter that followed the eruption loaded the atmosphere with aerosols for years afterward, creating sunsets across Europe of unusual intensity and color. Turner may have been painting accurately. The sky he saw may have genuinely looked different from the sky we see today. This is the sky as a mirror of atmospheric chemistry. Its color is not intrinsic to it. Its color is a readout, a visual display of the current state of the air between you and the sun. Breathe in. You are inside the instrument. The sky you see is partly determined by the air you are standing in. Let us go further. The sun itself is deceiving you. When you look at the sun, not directly obviously, but when you think about the sun, when you conceptualize the light that is filling the sky around you right now, you are thinking about it as the sun as it currently is, the sun that exists in this moment, the energy source that is powering the biosphere of this planet as we speak. But the light reaching you right now left the sun approximately 8 minutes and 20 seconds ago. The sun you see is 8 minutes in the past. If the sun were to suddenly cease fusing hydrogen in its core at this exact moment, you would not know for 8 minutes and 20 seconds. You would continue going about your life. The sky would continue to be blue. The warmth would continue on your skin, and then, 8 minutes later, the light would go out. This is trivial compared to the time delays of the stars, but It is worth sitting with because it illustrates something important. Even the most ordinary light you experience, the daylight you live your entire life in, is not the present. It is a message that arrived 8 minutes ago from a source you cannot observe in real time. There is an even stranger version of this when you consider what you would see if you could look inside the sun. The energy that is currently arriving at Earth as sunlight did not originate at the surface of the sun. It originated in the sun's core, where hydrogen fusion reactions produce gamma-ray photons. Those photons are so energetic and the interior of the sun is so dense that they cannot travel in a straight line. They are absorbed and re-emitted constantly, following a random walk through the solar interior, bouncing between hydrogen plasma particles, gradually losing energy, gradually working their way outward. This process takes time, a very long time. Estimates vary, but the generally accepted figure is that the photons we receive today as visible light took somewhere between 10,000 and 170,000 years to travel from the core of the sun to its surface. After that, the 8-minute journey to Earth is trivial. The sunlight warming your face right now was created in the sun's core between 10,000 and 170,000 years ago. It was produced in the form of gamma-ray photons, somewhere between the early Upper Paleolithic and the end of the last ice age, and has been bouncing around the sun's interior ever since, gradually changing in character, gradually making its way outward, finally emerging as visible light about 8 minutes before it reached your skin. You are not being warmed by the sun. You are being warmed by a nuclear reaction that happened when your ancestors were living in caves. Now let us look further still, past the stars you can see, past the galaxies, past the edge of the observable universe. And here is where the sky's deception becomes not just strange, but absolute. There is a boundary. It is not a wall or a physical surface. It is not a place where space ends. It is something more fundamental and more final than any physical barrier could be. It is the edge of what light can tell us. The universe is 13.8 billion years old. Light travels at 300,000 kilometers per second. Therefore, the maximum distance from which any light can have reached Earth since the Big Bang is approximately 13.8 billion light-years. But the universe has been expanding the entire time. The galaxy that emitted the light we are receiving today as the most distant signal was not 13.8 billion light-years away when it emitted that light. It was much closer. But space itself expanded while the light was traveling, carrying the galaxy to a much greater distance. The actual current distance to the most remote objects we can observe is approximately 46 billion light-years. Everything within that 46 billion light-year sphere is, in principle, observable. Everything beyond it is not. Not because our instruments are too weak, not because the light is too faint, but because the light has not had time to reach us yet. Those galaxies exist. They probably contain stars and planets and possibly life. But the light they have emitted since the Big Bang has not yet crossed the distance to Earth. The universe is younger than the travel time. We are structurally cut off from those regions. And it is worse than that. The universe is not just expanding. It is accelerating in its expansion. The galaxies at the edge of the observable universe are already receding from us at speeds that exceed the speed of light. Not because they are moving through space faster than light can travel, but because the space between us and them is expanding, and there is so much space between us and them that even the expansion of each tiny segment adds up to a recession speed greater than 300,000 kilometers per second. This means that for galaxies beyond a certain distance, approximately 16 billion light-years from Earth, the light they emit today will never reach us. The universe is expanding too fast. The distance is increasing faster than the photons can cross it. Those galaxies will never appear in any telescope we could ever build, no matter how sensitive, no matter how many years it operates. They are permanently inaccessible to us, causally disconnected beyond any possible observation. And as time passes, more galaxies will cross this threshold. The accelerating expansion will eventually carry more and more galaxies beyond the limit of communication. In the very long future, tens of billions of years from now, an observer in our galaxy will see a sky with only a few nearby galaxies still visible. Everything else will have receded beyond the horizon, their light permanently red-shifted out of detectability. The observable universe will have shrunk, not because space has disappeared, but because the separation between us and everything else will have outpaced the speed of information. Future astronomers in that distant era, if they exist, will look out at a nearly empty sky and conclude, based on the available evidence, that their galaxy exists in isolation. They will have no data about the 2 trillion galaxies that existed and that we can see today. The evidence will have been carried away by the expansion of space. They will measure what they can measure, build their cosmologies, and be profoundly wrong in ways they cannot possibly know. This is the version of our situation that should disturb you, not that we might be making mistakes, but that the universe has a built-in mechanism for erasing evidence. The most important information, the early universe, the large-scale structure of the cosmos, is encoded in light that is currently available to us and will become unavailable to our descendants as the expansion proceeds. We are in a brief window, a cosmological moment in which the observable universe is at its most informative, its most rich with structure, its most legible, before the evidence disperses, before the expansion carries the witnesses beyond reach. And we are spending this moment, in significant part, flooded with artificial light that prevents most of us from seeing even the stars nearby. But perhaps the most profound aspect of the sky's deception is not what we cannot see. It is what we can see and cannot identify. Almost everything in the universe is invisible to us, not because it is too far away, not because the light is too faint, not because our instruments are insufficient, because it does not emit light at all. The ordinary matter you are familiar with, atoms, molecules, protons, neutrons, electrons, the stuff that makes up stars and planets and gas, clouds and your body, constitutes approximately 5% of the total mass energy content of the universe. 5%. The other 95% is divided between 2 things. We cannot directly observe, cannot touch, cannot sample, cannot analyze with any instrument currently in existence, and cannot fully explain with any theory currently accepted. 27% of the universe is dark matter. Dark matter is not dark in the sense of being black or colored. It is dark in the sense of being invisible. It does not absorb, emit, or reflect light of any wavelength. It does not interact with electromagnetic radiation at all. It passes through ordinary matter as if ordinary matter is not there. Right now, as you lie here, dark matter particles are passing through the planet beneath you, through the room around you, through your body. They are everywhere in enormous quantities, and they do not interact with a single atom of your flesh as they pass through it. They are here and they are nothing. And yet dark matter is real. Its existence is as well confirmed as the existence of any of the particles described in our standard model of physics. We know it is real because of what it does to ordinary matter through gravity. The stars at the edges of galaxies are moving too fast. If the only mass in a galaxy were the visible stars and gas, everything we can observe, then the gravitational pull of that mass would be insufficient to keep the outer stars in their orbits. They should fly off into intergalactic space. They do not. They orbit. And the only explanation that fits the data is that there is far more mass in every galaxy than we can see. A vast, invisible halo of dark matter surrounding each galaxy, providing the gravitational scaffolding that keeps the visible matter from dispersing. The gravitational lensing of light around galaxy clusters also confirms it. When we observe distant galaxies through a foreground cluster, the light from the TOSL background galaxies bends around the cluster in arcs and rings. The degree of bending tells us how much mass is present. The mass inferred from lensing is consistently 5 to 10 times greater than the visible mass. The invisible mass is there. We can feel it. We cannot see it. Dark matter built the universe we see. It collapsed first after the Big Bang, forming the gravitational wells into which ordinary matter later fell. It organized the cosmic web, the vast network of filaments and nodes and voids that structures the distribution of galaxies across billions of light years. Without dark matter, galaxies would not have formed, stars would not have formed, planets would not have formed, you would not exist. The universe was organized by something we do not understand. The structure you see in the sky was built by forces you cannot observe. And then there is dark energy. If dark matter is strange, dark energy is stranger. It is not matter. It is not a particle or a field in any conventional sense. It is something so alien to our intuitions about physics that even the name is an admission of ignorance. We called it energy because we did not know what else to call it. Dark energy was discovered in 1998. Two teams of astronomers were studying a specific type of supernova, the explosion of a white dwarf that has accreted enough mass from a companion to trigger a runaway nuclear reaction. These Type 1a supernovae are remarkable because they always explode at approximately the same intrinsic brightness, which means they can be used as standard candles. By measuring how bright they appear in the sky, astronomers can calculate how far away they are. Both teams were measuring how fast the universe was expanding using these supernovae as their measuring sticks. They expected to find that the expansion was slowing down, braked by the mutual gravitational attraction of all the matter in the universe. They expected to measure the deceleration and use it to calculate the ultimate fate of the cosmos. Instead, they found that the expansion was accelerating, not slowing, speeding up. Something was pushing the universe apart faster and faster, overcoming gravity on the larger scales, acting as a kind of cosmic anti-gravity with no known source. Both teams spent months checking and rechecking their data. The result was confirmed. The universe was not decelerating. It was accelerating. There was something in empty space, in the vacuum itself, that was pushing everything apart. Something with negative pressure. Something that did not dilute as the universe expanded but maintained constant energy density as space grew larger, growing in total amount as more space came into existence. This thing, which we call dark energy, makes up approximately 68% of the total energy content of the universe. It is everywhere. It fills the space between the atoms in your body, between the planets, between the stars, between the galaxies. It is not nothing. It is something, and we do not know what it is. The leading hypothesis is that dark energy is a property of the vacuum, that empty space has a non-zero energy density, a cosmological constant first proposed by Einstein and then abandoned as a mistake, and then discovered to be real. But this hypothesis runs into a staggering problem. When physicists calculate how large the vacuum energy density should be, based on quantum mechanics, They get a number that is roughly 10 to the power of 120 times larger than the observed value. That is a discrepancy of a number followed by 120 zeros. This is widely considered the worst prediction in the history of physics. Something is profoundly wrong with our understanding of the relationship between quantum mechanics and gravity. Dark energy is not just a gap in our knowledge, it is a wound in our physics, and it constitutes 68% of everything that exists. Now let us add these numbers together. Dark energy, 68% of the IR universe. Dark matter, 27%. Ordinary matter, everything you can see, touch, weigh, analyze, describe, or even conceptually approach, 5%. When you look up at the sky and see a galaxy, you are seeing the luminous fraction of its ordinary matter, which is itself only a fraction of the ordinary matter in the galaxy, which is itself only 5% of the total mass energy of the galaxy, including its dark matter halo. And all of that galaxy is surrounded by, permeated by, riding on top of the dark energy that fills the space it sits in. You are seeing 5%. At best, in many cases, far less. The universe is 95% invisible. And not invisible in the way a distant star might be invisible, because it is too faint. Invisible in the way that something can be invisible, when it does not interact with light at all. When no photon that has ever existed has bounced off it, or been emitted by it, or been absorbed by it. The sky is not a window onto the universe. The sky is a window onto the small, thin, luminous fraction of the universe that happens to interact with electromagnetic radiation. Everything else is dark and silent and all around you, and you cannot see any of it. There is one more layer to this, one more dimension of the sky's deception that operates not at the level of physical reality, but at the level of human perception and what it means to know something. When you look at a star, you are receiving a signal, a real signal, photons that departed from a real physical object and traveled through real space to enter your eyes. But your eye does not see the star. Your eye sees a pattern of light stimulating specific photoreceptors in your retina. Your retina sends a signal through your optic nerve to your visual cortex. Your visual cortex processes that signal and constructs a representation. Your conscious mind experiences the representation. At no point in this process have you had direct access to the star. You have had access to a sequence of physical interactions, photon to retinal cell, to nerve signal to neural processing to conscious experience. Each step transforming and interpreting the previous step. Each step dependent on the biological machinery of a brain that evolved for purposes that had nothing to do with correctly representing distant astronomical objects. Your visual system is not a neutral instrument. It is a system shaped by millions of years of evolution to navigate a world at a scale of meters and kilometers, to identify food and predators and faces and obstacles, to make rapid decisions under conditions of incomplete information. It was not designed to look at stars. It was not designed to faithfully represent the color of scattered sunlight, or the true distribution of stars across the sky, or the three-dimensional structure of the galaxy you are embedded in. The sky you see is the sky your primate visual system constructs from the light that arrives at your retinas. It is a model, not a measurement. A representation optimized for survival in a specific ancestral environment, applied to a task it was never designed for. This does not make the sky less beautiful. It makes the fact that it is beautiful at all. That these patterns of ancient light, processed through the accident of primate visual architecture, produce an experience of wonder in a human mind. All the more astonishing, but it means that the sky you know is not simply incomplete because of light pollution, or delayed because of the finite speed of light, or misleading because of scattering effects, or concealing the invisible majority of the universe. It is also, at the deepest level, a construction of your own mind. A picture assembled from partial information, filtered through limited biology, compiled by a brain that is trying its best with what it has. The real sky is something you have never directly experienced and never will. You have only ever experienced a representation of the sky, mediated by physics and atmosphere and your own neurology. And now we arrive at the last and deepest question. If the sky is not what it seems, if everything we have described tonight is accurate and the totality of your experience of the sky is delayed, filtered again, obscured by artificial light, limited by biology, surrounded by invisible matter, bounded by a cosmic horizon beyond which no information will ever reach us, then what does this mean? Not as a question of physics, as a question of existence. What does it mean to stand outside on a clear night, look up, and feel, genuinely feel, in the wordless way that precedes all articulation, that the sky is speaking to you? That there is something up there that matters? That the darkness and the light and the ancient photons arriving after their long journeys and the incomprehensible distances all add up to something that is meaningful. You are not seeing the universe as it is. You are seeing a thin, delayed, partial, biologically constructed glimpse of its luminous fraction. And you are seeing it through a thick blanket of artificial light that modern civilization has thrown over the natural darkness. And it is still the most beautiful thing most people will ever look at. This is not a paradox to be resolved. It is the condition of being a conscious creature inside a universe that is vastly larger than consciousness can contain, looking out with instruments that were built for other purposes, across distances that mock the concept of distance, at a cosmos whose deepest nature is accessible to mathematics, but not to direct experience. The sky is not what it seems. It is delayed, it is filtered, it is incomplete. It is surrounded by a darkness that is not empty but full of invisible structure. It is bounded by a horizon that will never move. It is embedded in a context of dark matter and dark energy that your most sensitive instruments can barely characterize and cannot explain. It is screened from most of humanity by a glow of our own making. And yet, stand outside on a clear night, far enough from the city to see real darkness. Let your eyes adjust for 20 minutes until your rods have fully dark adapted and the sky has become something other than a ceiling. Watch as the Milky Way becomes visible not as a faint suggestion, but as a structure. A dense, textured band of light arching from horizon to horizon, the disk of our own galaxy seen edge on, 100,000 light-years from side to side. What you are seeing is not the galaxy as it is. It is a mosaic of pasts, each star a different age of transmission, the whole thing arriving at your eyes simultaneously and appearing, by the miracle of your visual cortex, as a coherent image. You are seeing ancient light. You are standing at the center of a sphere of time, receiving messages from the past in all directions simultaneously, your brain assembling them into a single moment of perception. And the Milky Way casts a shadow, not metaphorically, an actual shadow on the ground in front of you, cast by the combined ancient light of 400 billion stars, gathered over millions of years of travel, arriving at your planet on a clear night when you have found a place dark enough to receive it. Stand in that shadow for a moment. Everything about the sky that seems wrong, the incompleteness, the delay, the invisibility of 95% of reality, the artificial glow that most of us live inside. All of that is also a precise description of what it means to be a finite, embodied, biological creature trying to understand a universe that was not designed to be understood by anything. The sky is not what it seems. What it seems is a flat ceiling with scattered lights. What it is, even the fraction we can access, even the ancient partial signal that gets through, is one of the most extraordinary things that exists anywhere. The light is old, the stars are far, the sky above you is screaming with information in every direction, in wavelengths you cannot see, about events that have already concluded from sources embedded in a darkness that will never be fully visible to any instrument. And on a clear night, if you go somewhere dark, you can see it. Not all of it, not even most of it, but enough to know that you are small and alive and briefly here, receiving signals from a cosmos that has been burning since long before you existed and will go on burning long after you are gone. The sky is not what it seems. What it seems is ordinary. What it is, even in glimpses, even through all its layers of deception, is anything but. Sleep well.